Hi everyone. In this video, I'm going to go over some test review questions for the circuits test. This is from Wednesday's page of the week 27 packet. So the first question is kind of a three-part question. It says a 5 ohm resistor, a 10 ohm resistor, and a 15 ohm resistor are connected in parallel with a battery. The current through the 5 ohm resistor is 2.4 amperes. Using the circuit symbols found in the reference tables for physical settings/physics, draw a diagram of this electric circuit. I put draw in bold because we're not doing any calculation here, we're just drawing the circuit, and it has to use the circuit symbols found in the reference table. I see that I have 3 resistors, 5 ohm, 10 ohm, and 15 ohms, and they are connected in parallel. So I drew my circuit like this, and it also mentions a battery. Every circuit has to have a battery, so this is what my circuit looks like. The order of these resistors does not matter, but it's important that they're connected in parallel like this. A common mistake that I've seen is adding this extra bracket with just a straight line here. You can't include that because then it looks like there's this extra wire just connecting another pathway. And in real life, if you did that, what would happen is all of the current would just go through this pathway because it's the easiest one to go through. Theoretically, there would be no resistance at all, so we wouldn't have any current through those other 3. So don't include this extra pathway, just one path for each resistor. So this is the correct way to draw it. If you'd like to label the 2.4 amperes next to the 5 ohms, you can definitely do that, and it might help you later in the question, but it's not mandatory. Question 2 is still related to this circuit. So it says calculate the amount of electrical energy expended in the 5.0 ohm resistor in 2.0 minutes. This show all work, including the equation and substitution with units, means this is a 2-point question. You'll get 1 point for the work with the correct formula and 1 point for the answer with the correct unit. I started by annotating with cubes. I circled all my numbers and units. There are a lot of numbers given, but it might help to circle them. I put a box around current. I could have also boxed all the resistors, parallel, battery, but I put a box around current to draw attention to that. And then I underlined electrical energy because it says calculate the amount of electrical energy, so that's what I'm here to do. That's what I'm looking for. Something that I've seen some of you do during class is add on these variables next to whatever you're given. So you can write I next to 2.4 amperes to remember that that's my variable for I, or that's what I'm going to plug in for I. Electrical energy, the variable for that is W, so you can put a W. 5 ohms is the resistance, 2 minutes is the time. So that's just another strategy that you can use if you'd like. And it really helps me list out my variables. I know I'm looking for W, so I have W equals question mark. I know I is 2.4 amps right here, and that's also why I boxed current, because the current through the 5 ohm resistor is 2.4 amps. R is 5 ohms, and T is 2 minutes. Now one of those is not the correct unit. Minutes is not the SI unit for time. I'm supposed to have that in seconds. So 2 minutes is the same thing as 120 seconds. And I would get that just by doing 60 seconds per minute times those 2 minutes. You could also do 60 plus 60 because that's 2 minutes. So those are my variables. I need to go to the reference table to find a formula. So here, I definitely need one of these because I'm looking for W. And I want to pick one that has all these variables that I already have. So for example, I don't have power listed, so I can't use this one. I don't have volts listed, so I can't use that one. I can use this one, W equals I squared RT, because I have all of those values. So I'm going to start with W equals I squared RT, and then I can plug in my variables, or my values. I squared becomes 2.4 squared, R becomes 5, and T becomes 120. As long as you include units here on this, when you list your variables, you don't technically have to include them here in your equation, but as always, it might help you, so feel free. And then I just plug that right into my calculator, 2.4 squared times 5 times 120. And that gives me my answer, 3,456 joules. Question 3 says, a 20 ohm resistor is added to the circuit in parallel with the other resistors. Describe the effect the addition of this resistor has on the amount of electrical energy expended in the 5.0 ohm resistor in 2.0 minutes. I put this part in bold, describe the effect, because that should tell you that we're not doing an actual calculation. We're just talking about, did it increase, did it decrease, or did it stay the same? More specifically, did the electrical energy of that 5 ohm resistor, did that increase, decrease, or stay the same? So what's happening here? They told me I'm going to add a 20 ohm resistor, so I added that on in parallel. And I want to describe the effect that it has on the electrical energy, so W, through the 5 ohm resistor. I would technically be able to solve for W the same way that I did last time. I could still use W equals I squared RT. R stays the same. They already told me it's a 5 ohm resistor. 2 minutes is the same number. Again, I would want to convert that into seconds, but it's still the same. That didn't change. The last question would be, did the current change? And the answer is no. The current through this resistor does not change when you add on other branches. So each individual branch kind of doesn't get affected by another branch in a parallel circuit. If they were asking me about the total current or like the total energy, then that would be a different story. But since they're talking about one specific branch, the current doesn't change, the resistance doesn't change, the time doesn't change. What that means is the electrical energy does not change. In other words, it remains the same. So that would be your answer for question 3. Question 4 says a 25 meter length of platinum wire with a cross-sectional area of 3.5 times 10 to the negative 6 meters squared has a resistance of 0.757 ohms at 20 degrees Celsius. Calculate the resistivity of the wire. I started by annotating using cubes. I circled all of my numbers and units. I skipped over that 20 degrees Celsius. We don't actually ever use temperature, so we don't have a variable for that. So that's why I skipped it, but you could have circled that as well. And then I boxed these keywords. These are all variables. Length is a variable, resistance is a variable, cross-sectional area is a variable. And then I underlined the question, calculate the resistivity. That's going to help me list my variables. Resistivity is this Greek letter. It's pronounced rho. It looks mostly like a lowercase p, but when I talk about it, I'm going to be using the word rho. So rho is question mark, L is 25 meters, A is 3.5 times 10 to the negative 6 meters squared, and R is 0.757 ohms. I need to go back to my reference table to find an equation. And this is the only equation with rho in it, and that's what I'm looking for, so I kind of have to use this one. And it works out, though, because I have R, I have L, and I have A. Typically, when we use this equation, we're solving for R, so I can just plug in my numbers and then plug it into my calculator. But this time, we're solving for rho, so it might be a little bit trickier. I'm going to use the triangle method, or the pyramid method, and see if that can help me out. Whatever is in the numerator goes in the top of the pyramid. So I have rho L, and then R is on the left, and A is on the right. I can't really get rho by itself with this method, but I can get rho times L by itself, and that might kind of get me on the right track. So if I cover up rho times L, I would see that it's equal to R times A. So this is how I'm going to rearrange my formula, and that's going to be my starting point for this problem. Rho L equals RA. Rho stays rho because that's what I'm looking for. L becomes 25, R becomes 0.757, and A becomes 3.5 times 10 to the negative 6. And you can see that having those values listed here makes it really fast to just plug those numbers in. my next stop is going to be, or my next step is going to be multiplying these two numbers together. I can't do it all at once because I can't, like, there's the equal sign right there in the way, so I'm just going to multiply these two numbers first. That's what I get. If you got it in a decimal form, that's fine too. And now to get rho by itself, I want to divide both sides by 25. Right now, rho was being multiplied by 25, and I want to do the opposite of that, so that's divide. So that lets me cross out 25, and I'm going to be left with rho equals this divided by this. When I put that in my calculator, I get my answer, 1.059 times 10 to the negative 7 ohms times meters. I encourage you to go through questions 5 through 8 on your own as in preparation for the test. And the last thing that you should make sure to study is all of these variables and units. Do your best to fill them in on your own. You can pause the video here. And here are the answers. This is something that ideally you would have memorized by the time that you take the test.